Imagine asking your database a simple question, like, show me customers who spent more than average last quarter. You expect a quick answer, but often the AI generates SQL that fails to execute. It tries again, rephrasing the query, but the same error pops up. Even advanced models like GPT-4 stumble on complex joins or ambiguous columns. Most systems just keep retrying, making similar mistakes repeatedly. This is a common frustration in the world of text-to-SQL, the lack of systematic error handling. Today, we'll explore how a new multi-agent framework, SQL of Thought, changes the game by diagnosing and fixing SQL errors with precision. Traditional text-to-SQL systems rely on a single large language model call to translate natural language into SQL. When the generated query fails, the system simply retries, maybe tweaking the prompt. But there's no deep understanding of what went wrong, no targeted fix based on the error. Common issues include schema mismatches, ambiguous columns, missing joins, and incorrect aggregations. Without a systematic approach, these errors persist, making the process unreliable and frustrating for users. Clearly, a smarter, more structured solution is needed. A breakthrough paper from the Max Planck Institute and AWS GenAI introduced SQL of Thought, a multi-agent framework that systematically categorizes and corrects SQL errors. Instead of blindly retrying, this approach uses 6 specialized agents, each with a unique role. The system classifies errors into 31 types across 9 categories, then applies targeted corrections. This method achieved an impressive 91.59% accuracy on the Spider benchmark, setting a new standard for reliability in text-to-SQL translation. Let's break down the SQL of Thought pipeline. The process starts with the schema linking agent, which identifies relevant tables and columns. Next, the subproblem agent decomposes the query into SQL clauses. The query plan agent then uses chain of thought reasoning to create a step-by-step execution plan. The SQL agent generates executable SQL, and the DB execution engine runs it. If an error occurs, the correction loop activates. The correction plan agent diagnoses the error, and the correction SQL agent applies a targeted fix. This loop repeats until the query succeeds or a maximum number of attempts is reached. A core innovation of SQL of Thought is its error taxonomy. The system classifies SQL failures into 9 major categories and 31 specific error types. Each error code provides concise identification, helping the agents understand exactly what went wrong. For example, if the error is ambiguous, the system knows to add table prefixes. If it's join missing, it identifies the join path using foreign keys. This taxonomy transforms debugging from guesswork into a systematic, repeatable process. Traditional systems only see execution errors like column not found or ambiguous reference. They retry with minor changes, often repeating the same mistake. SQL of Thought, however, categorizes the error and applies a known solution pattern. For ambiguous columns, it adds table prefixes. For missing joins, it finds the correct join path. For aggregation issues, it adds the necessary group by clause. This systematic approach turns debugging into a science, not an art. To test SQL of Thought in action, the author built a working demo using the Chinook database, a realistic music store schema with 11 tables and complex relationships. The backend uses Node.js, Express, and DuckDB for SQL execution, while the frontend is built with Vite and vanilla JavaScript. The system leverages OpenAI's GPT-4o-mini for fast, cost-effective language processing. Real-time updates let users watch each agent's step, from schema linking to error correction, making the process transparent and educational. The schema linking agent is the first specialist in the pipeline. It receives the user's natural language question and the full database schema, then identifies only the relevant tables and columns needed for the query. For example, for a question about top-selling tracks, it pinpoints the track, invoice line, album, and artist tables, along with their relationships. This focused approach ensures that subsequent agents work with just the necessary information, reducing confusion and error. Next comes the subproblem agent. It takes the schema-linked output and breaks the query into its SQL clause components: select, from, join, where, group by, order by, and limit. For example, a query for top tracks is decomposed into selecting track names and revenue, joining tables, grouping by track, and ordering by revenue. This structured breakdown makes the logic explicit and prepares the way for step-by-step reasoning. The query plan agent uses chain of thought reasoning to create a step-by-step execution plan. It takes the question, schema, and subproblems, then outputs a numbered list explaining the logic. For instance, it might start with the track table, join invoice line, calculate revenue, group by track name, and order by total revenue. This reasoning step helps prevent logical errors before any SQL is written, ensuring the query makes sense from start to finish. Once the plan is ready, the SQL agent takes over. It converts the step-by-step plan into executable SQL, handling syntax, formatting, and table aliases. This agent ensures that the generated SQL is not only correct in logic, but also in structure, ready to be executed by the database engine. By separating planning from generation, the system reduces the risk of both logical and syntactical errors. The DB execution engine runs the generated SQL. If the query succeeds, results are returned. But if it fails, the correction loop springs into action. The correction plan agent inspects the error, classifies it using the taxonomy, and devises a fix. The correction SQL agent then rewrites the query based on this plan. This loop continues diagnosing and repairing until the query executes successfully or the maximum number of attempts is reached. This is the heart of SQL of Thought's robustness. Let's see the system in action with a straightforward query. What are the top 5 best-selling tracks by total revenue? The schema linking agent identifies the necessary tables. The subproblem agent breaks down the query. The query plan agent reasons through the logic. The SQL agent generates the correct SQL, and the DB engine executes it. The result? 5 rows returned in under 3 seconds, with no errors. This demonstrates the pipeline's smooth operation when everything goes right. Now for a more challenging example. Get all invoice items with their unit price and track unit price. Both invoice line and track tables have a column named unit price. The first attempt fails due to ambiguous column reference. The correction agent inspects the schema, identifies the ambiguity, and applies table prefixes. On the next try, it discovers a wrong column name in the join condition. After inspecting the schema again, it finds the correct column track ID and rewrites the query. The final attempt succeeds, returning over 2,000 rows. This showcases the power of taxonomy-guided correction. What makes SQL of Thought stand out is its systematic approach to error handling. Instead of random retries, each error type has a diagnostic procedure and a fix strategy. The correction agent inspects the actual schema, identifies the error category, and applies a targeted solution. This dynamic multi-agent collaboration ensures that errors are not just patched, but truly understood and resolved, making the system reliable and transparent. While SQL of Thought is powerful, it has some limitations. There's no value retrieval agent, so the system can't proactively check actual data values for filtering. This can lead to failures when user phrasing doesn't match database values. The multi-agent setup also increases token usage and latency compared to single-agent systems. Future improvements could include value inspection, fine-tuned models for each agent, query plan, visualization, and support for more database types. These enhancements would make the system even more robust and user-friendly. SQL of Thought represents a leap forward in text-to-SQL reliability. By systematically categorizing errors and applying targeted fixes, it transforms SQL generation from a trial and error process into a diagnostic science. The multi-agent architecture, guided by a detailed error taxonomy, delivers high accuracy and transparency. As the field evolves, adding value inspection and optimizing performance will make these systems even more powerful. For now, SQL of Thought sets a new benchmark for robust, production-ready text-to-SQL solutions.